Hi, okay, today we want to discuss the easier way how to resolve vector. Okay, first we can look at a few examples here. So this is F1. So this is the incline arrow. So these types of arrow we call as a incline. So incline vector. So for the example 2, this is incline arrow. So for the incline arrow, incline vector, so we need to resolve into S and Y component. Okay, like this. This is incline arrow vector. So we need to resolve. And this one, this is the incline vector. So next, what we need to do is, okay, angle. So all the vectors must incline at certain angle. So let's say we use here the angle is 30. Okay. For the second example here, 30 degrees. Okay, here maybe 40 degrees. Okay, here let's say 50 degrees. All right. Step 1. For the step 1, make sure all the angle, this angle must at x axis. Right? So let's say for the first example, the angle is 30 degrees at x-axis. So we can use this angle. Okay, let's say for this one, this is also 30 degrees. So this is the x-axis. So we can use this angle. Same with this one, 40 degrees below. This is below at x-axis. So we can use this angle. But for this one, okay, look at a 50 degrees here. So 50 degrees here actually lie at a x-axis. Okay, but make sure we always use the angle at x-axis. So how? So by doing the mathematically, so we get here 40 degrees. So we choose 40 degrees when we want to resolve it. All right. Okay, next. What we need to do next step is, okay, to resolve into S and Y axis, okay, we draw a simple box. Okay. We draw a simple box, okay, around the inclined arrow, around the example here. So we draw a green lines box. Okay, settle. After that, we need to draw the resolving arrow. So I use the green color to show you how to resolve into X. So start from the origin. This is the corner. So from origin to the x-axis corner, so this is your resolving vector at x. This is the y corner. So from the origin to this corner, so this should be your y-axis. Alright, next. What about for this example? So when we want to resolve at y, okay, should be like this. Okay, this is resolving at x. For this kind of example, this is the resolving vector at x. This is resolving vector at y. And the last example, okay. This is the resolving vector at y, and this is at x. Okay, next. Okay, we want to label for the x-axis here. So this is your x-axis. Okay, so we need to label as f1x. This is your y-axis, so we need to label as f1y and put the arrow here. Okay, next, look at this angle. Okay, so we always use the angle at x-axis. Again, we always use the angle at x-axis. So, for the resolving, the magnitude for the f1x become f1 cos 30. Then, for the magnitude f1y, we can write as f1 sin 30. Okay, next, we need to check the direction, either positive or negative. So, by looking at the arrow here, for the green arrow here, so upward. So, the direction become positive sign. For the x-axis here, the green arrow is to the right. So, this direction should be positive sign. Okay, next. If you want to substitute directly, okay, you can write in terms of positive F1, the magnitude is 10. Actually, refer to this example. The magnitude is 10 Newton. Okay, so sin 30. So the direction should be positive. And then for the f1x, you can substitute as 10 for the f1 cos 30. And then put the sign here, positive to the right. Okay, try for this example. Let's try together. Okay, now look at the angle. So your angle is at x-axis. So we can use this angle. Next step, This is your F2x. So why use F2? Because of the example here is F2 equal to 20 cos 30. And check direction to the right, positive. Okay, next. For the y-axis here, F2y equal to 20 sine 30. So the sign is downward. So downwards means negative direction. And so on. Alright. Good luck.